Okay, the area of a sector of a circle is what we're working on now. And to find it, capital A stands for the area of a sector. The sector kind of looks like a slice of pizza, you know? And to find that, you take 1/2 theta, which is the angle measure, times the radius squared. Not going to go into how they figured that out, but that's how you calculate it. And activity 5 says in a central pivot irrigation, a large irrigation pipe on wheels rotates around a center point. A farmer has a central pivot system with a radius of 400 meters. If water restrictions only allow her to water 140,000 square meters a day, what angle should she set the system to cover? I live in Indiana, and I drive up and down Interstate 65 and see lots of farmland. So I just Googled some pictures for you in case you don't know what one of these things looks like. So here is the central pivot point of this water irrigation system. And you can see that it has a bar going out in it, and you can kind of see in the picture there are spewing water, but this thing swings around. It rolls around this pivot point. And so I've got another picture. It's kind of zoomed out, and you can see from this, let's see here. Use a bright pink here. Right here is that system, and as it spins around, you can see it's right there. I can see the little, here's the main pivot point, and then this thing has wheels on it. This thing, they all have wheels on it. And as it rotates, as this whole bar rotates around the circle, it creates this. You can see each one of these creates a little subcircle in the middle, because that's the tires. The tires on this thing are dragging in the crops and tearing it up, so you don't want to plant anything right there. So it's going around in a circle. Okay, and she's only allowed, and they're saying she has 400 feet. So the distance, I'm going to guess, let's get a little smaller on this, from the center out, this whole distance, that is the 400 yards that she has. So the question is, what's the angle here that she can rotate it so that all of this in that circle, it looks like a pizza slice, is going to get watered? Does that make sense? What's the question? In a central pivot irrigation, a large irrigation, a farmer has a central radius of 400 meters. Okay, so here's the center of that pivot system. It goes out. I don't know why this does this. 400 meters. And it's going to rotate. Okay, pretend that's a good circle. And she's allowed to water 140,000 square meters a day. That is the area. This is A. And we're trying to figure out, let's say this bar rotates over to here, so that this is the part of her circular garden of corn or whatever that's going to get sprayed with water that day. So I know A, I know R, I don't know theta. Theta, this here is theta. So I have to take that formula, 140,000. So in place of, we've got A equals 1/2 theta times R squared. A is the 140,000 square meters, and theta is what I'm looking for, and R is 400 meters squared. So I ran out of room here. Let me erase this. So what I need to do is solve that equation. So come on up here. You've got 140,000 equals, when you take 400 and square it, take 400 and square that, I'm going to get 16 plus 40, so 160,000. But then I want half of that, so my brain, sorry. 400 squared is 160,000, and you want half of that, so divide that in half. That's 80,000. So this is going to be 80,000 theta, and then just divide both sides by 80,000 to figure out what theta is. Okay, so 140,000 divided by, whoops, one too many zeros there. 140,000 divided by the 80,000, and we get 1.75 exactly. It says, what am I looking for? What angle should we set the system to cover? Write the answer in radian measure to 2 decimal places. Oh, I guess this is already in radians. Where is my, oops, there's the pictures I was looking at. 1.75, is that it? Is it already in radians? How'd I do? Yay! There you go. And you can see their explanation. They did exactly what I did. Ta-da! Now you know everything you need to know about irrigation systems. There you go. That's how they water all those corn. Yeah, Indiana, we either plant corn or soybeans. That's pretty much all we have on our farms in Indiana.